Okay, welcome to Blood3. Where we're talking about leukocytes, thrombocytes, and we're getting into hemostasis, which is the stopping of bleeding. Okay, so leukocytes, white blood cells, form and function. They have a bunch of different shapes. They fall into what's called granulocytes. They have 8 granulocytes. And their function is to fight infection. And that's their role. So here are the types. Like I said, the granulocytes. And you can see that they're, on the microscope, they have granules in them. And these are regular cells. These are really the only blood cells that are really cells. They have the nuclei, all the organelles that a regular cell has. In the microscope, the granulocytes have these like lobular dissected nuclei, and they have granules. 3 types: neutrophils, most common, eosinophils, and basophils. And they all have a separate role. Neutrophils are most common. They're bacteria fighters. Eosinophils fight parasitic infections, multicellular parasites. Basophils secrete histamine and heparin, and these help start inflammation. Inflammation is an immune response, and it is a good thing. When you're infected or you have a damage, chronic inflammation is a bad thing. But anyway, and then you have the A granulocytes. There's 2 types there: lymphocytes, and there's 2 of those. B and T lymphocytes on the lymphatic tissue, and then monocytes become what are called macrophages, which are large phagocytic cells. And if you have an infection and you want to find out, you're not sure what you're infected, you can go to the physician and get what's called a differential white cell count, and it will measure how many of these individual types of white blood cells you have, and I'll give you an indication of if you're fighting some kind of bacteria, virus, multicellular parasite, or you just have some kind of inflammation, something else. You can tell that by getting differential white cell count. All right. Life cycle of leukocytes is quite different than red blood cells. They usually last a lot longer because they're full-fledged cells that can be parent cells. Production is called leukophoresis. It's in bone marrow also. These cells, some of these cells can actually leave the cardiovascular system. They squeeze out between the cells lining capillaries and can go throughout the tissues called immune surveillance, looking for foreigners. They're stimulated by colony stimulating factors, which are mostly paracrines called leukotrienes. And we'll talk more about those in the immune system when we get to it. And these are stimulated by the presence of antigens, foreign proteins in the body from wherever. Some of these white blood cells are very long lived. Hopefully they might last your entire life. You get vaccinated, you get something. That should last your whole life. You make a clone of what are called B lymphocytes. They're in your lymph nodes, and they remember their exposure to an antigen, and they make antibodies right away, and you have antibodies in your blood now from that exposure to the agent. So hopefully they last your entire life. And you have immunity from this disease your whole life. After you get infected and you live through the disease, you have lifelong immunity. They are phagocytosed upon death. If they do die, these phagocytic cells are macrophages that come along, surround them, chew them up, and do it. Okay. Disorders. Just like in red blood cells, there are disorders of too few or too many. Leukopenia is too few, And this could be due to a particular disease, HIV, in fact, would cause leukopenia, too few blood cells, or some toxins can cause that as well. Leukocytosis, too many, and that's usually cancer, too many. And this is leukemia. Cancer of the bone marrow, making too many white blood cells. And so the hemostasis, this is the stopping of bleeding. You just think of that as clotting, but clotting is actually just one part of hemostasis, which is the overall stopping of bleeding. Platelets have a lot to do with this, also called thrombocytes, even though they're not cells, they're fragments of cells. And they are usually inactive if you haven't injured yourself, if you haven't cut into a blood vessel, they're inactive. Perhaps they're inactive because of a protein called prostacyclin. It's a repellent. So the inside of blood vessels are very smooth and actually repel the platelets from sticking to the inside of your vessels. You don't want platelets sticking to inside of blood vessels that are not damaged. Hang on a second, I'm going to pause for a moment. Okay, so let's continue on to the next slide. So here, the three stages of hemostasis. When a vessel is injured, first is vascular spasm. Blood vessels constrict or limit blood escape. So when you damage smooth muscle, it reflexively contracts. Right? Then there's what's called platelet plug formation. Platelets arrive at site of injury and stick to exposed collagen fibers. When platelets get exposed to collagen, they really form this platelet plug. It plugs up the opening. This is not a clot. You haven't gotten a clotting yet. Okay. Coagulation phase 3, now it's the clotting. A coagulation cascade converts inactive proteins to active forms and forms of blood clot. So what happens is platelets what are called degranulate. They break open and they release these chemicals into the blood that's going to cause a protein cascade of all of these protein factors that are in the blood that are just dissolved in the blood in fibrinogen factor. They have numbers, and they're all there to 13. And the higher number, the later they were discovered. And there's a whole series of them. And we look at this cascading effect of what factor affects what factor later on. We'll get actually into clotting more detail. And the whole idea is to form a fibrin clot. Okay. So production of platelets is thrombopoiesis. Deficiency is called thrombocythemia. And the process, okay, so here's the process of hemostasis. Vascular spasm first, platelet plug formation. And the prostacyclin is the protein that prevents platelet plug formation, prevents platelets from sticking to inside the blood vessels. And some people, they start to stick, and they can lead to cardiovascular disease. This is one of the, you've seen the ads on TV for these drugs that inhibit platelets from being sticky. You don't want platelets to be sticky. When they degranulate, they release several chemicals. One of them is called thromboxane A2, which is a paracrine. It's a cosanoid that causes aggregation of platelets, more degranulation, and vasoconstriction. get platelet degranulation. So you secrete vasoconstrictors, thromboxane A2 being one of them. They stick together to form plugs. They secrete procoagulants, which stimulates the cascading process of these proteins. And interesting thing is that as soon as platelets degranulate, they start to basically cause a blood clot. And this is something called factor 12 or Hagelin factor. But Hagelin factor also starts the process of clot dissolving. So here's the interesting thing. As soon as the platelets degranulate, clot formation starts. But also clot dissolving starts. If the clot hangs around long enough, it so slowly starts to dissolve. But both of those processes start at the same time. It's just that the clot formation is really quick, and as in a few minutes, 2 to 8 minutes, you flush the clot. The process of clot dissolving takes days, maybe even a couple of weeks. But they both start at the same time. The clot dissolving is much slower than the clot formation. Chemotactic agents are released. This chemotaxis is cells following a chemical trail. You want to bring in neutrophils. Those are the first guys that show up. You want to bring in, because every time you cut yourself, bacteria gets into the wound. You got to fight those bacteria. And you want to bring in white blood cells, particularly neutrophils. And then phagocytic, and they come in and they start eating up bacteria. They squeeze out from the wound between the cells lining the blood vessels. And we'll see this a lot more when we get into inflammation. Because your tissue becomes inflamed when you get injured. It's a good thing. Secretion of growth factors. There's growth factors that will then turn on mitosis in the connective tissue, nearby the wound, the smooth muscle cells that line the blood vessels. They are going to be stimulated by mitosis and repair themselves. These chemicals are inside platelets. The whole purpose of coagulation, clot formation, is the production of this protein called fibrin. And fibrinogen is the precursor to that, and ogen means it's inactive. Fibrin is when it's active, it forms this blood clot. All right. So you need lots of things for coagulation. You need calcium for one thing. You need these clotting factors, 1 through 13, and you need vitamin K. Those are absolutely required for clotting. If you don't have any of these, your blood's not going to clot. Well, if you have no calcium, you're going to get any. But if you're missing one of the clotting factors, then that's called hemoglobin. We'll get to that later on. Okay. There's an extrinsic and intrinsic mechanism. Extrinsic means it's outside of the cardiovascular system. And there are chemicals that are released by damaged cells, like in connective tissue and skin cells, that release we call Hagelman's factor. Okay. Damaged tissue releases what's called thromboplastin factor 3. Goes to factor 12, which is Hagelman's factor, to activate factor 10. Now this is a very quick mechanism, but it doesn't make much of a clot, but it's really quick, so it really starts the process going on. The intrinsic mechanism, it happens inside blood, and that's why it's called intrinsic. And it's a little bit slower. But so first the intrinsic mechanism fires up immediately, and then intrinsic mechanism is more complete. Takes a little bit longer, but and actually they both do the same thing. They both activate factor 10, although the intrinsic is a little more complicated than the extrinsic. That's probably why it's a little bit slower. Intrinsic mechanism. So factor 12, again, is released. That activates factor 11, activates factor 9, activates factor 8, and then activates factor 10. So, and the way to remember it is it's really goes backwards, except 9 and 10 are reversed. So it goes from 12 to 11, back to 9, back to 8, and then the 10. And so you see both intrinsic and extrinsic mechanisms do the same thing. They activate factor 10. And then, after you have factor 10 activate, now we have what's called the common factor. And factor 10 activates prothrombin activated. Thrombin is, so this prothrombin is another factor in your blood that's inactive. When prothrombin activator is activated, it makes thrombin, which converts fibrinogen into fibrin. Then factor 13 converts fibrin into fibrin polymer, and that's the actual clot. Beta clots. After the clot is made, it slowly starts to retract due to a protein called actinomyosin that's in the clot. And that pulls together the cut ends a little bit of the wound. Also in platelets, as I mentioned, growth factors, which now stimulates the mitosis in smooth muscle and connective tissue and skin to repair the damage as the clot is still there. And here, right here, is a figure from the book that shows the intrinsic pathway on the left, extrinsic pathway on the right, common pathway in the middle that leads to fibrin polymer. As you can see, other factors are needed factor 5, the common pathway you have factor 2, you need calcium, you have factor 5. You don't have to know in that detail. You should know what factor interacts, what factor in two pathways, and actually in 3 pathways: the intrinsic, the extrinsic, and the common. Thin clots. So then we have, after the clots form, actually, remember, as the clot is formed, it already begins to dissolve. This is called fibrinolysis, dissolution of the clot. Over the course of days, or even a couple of weeks or so, the clot is finally going to dissolve, becomes small enough, and it just falls off. And this is how this happens. And this is interesting too, factor 12. That initiates the clot formation, also initiates clot dissolution. And this pathway is not completely in your book. So pay close attention to this. I don't know why, it should be. Factor 12 activates kallikrein. Kallikrein activates plasmin. Plasmin is another enzyme, and the thrombin makes clots. Plasmin dissolves clots. It also promotes the formation of more factor 12 that activates more kallikrein and slowly dissolves fibrin polymer, and plasmin slowly dissolves the clot. All right. So the balancing act between clot formation and prevention of clot formation in your blood, it's really important for your blood to clot. But it's also really important to prevent inappropriate clot formation. So clot formation is favored when a blood vessel is damaged, narrowed, inflamed, or when blood flow. Oh, that's a typo. Blood flow is restricted or slowed. Now here is this. I pulled this from a different book. Off the web someplace. This is the fibrinolysis and that this particular pathway is not in the book. So it's good to look over this slide carefully. All right. Okay, sympathetic loss of response to blood loss. Loss of 10% of blood initiates sympathetic nervous system called general vasoconstriction, increased heart rate, increased force of contraction, maintaining blood pressure. And blood is also preferentially diverted to brain and heart. So if you lose a lot of blood, 10%, you have a sympathetic response that shuts down everything in your body. Causes vasoconstriction, and you end up sending blood to your brain and heart preferentially to keep yourself alive. You lose more than 40% of your blood volume, adequate blood pressure cannot be sustained, and this is death. Okay, inappropriate clotting. Prevention. Remember, platelets are repulsed by prostacyclin inside blood vessels. The clotting factors are diluted in the platelets are spread out in the blood. There are anticoagulants present called antithrombin and heparin in the blood to help prevent clot formation. Well, we're going to talk about that. So clotting disorders. Let's talk about clotting disorders. Not enough hemophilia. You're missing one of the clotting factors, and you need all of them. You're missing just one. It's going to cause hemophilia. And this is the most common is sex-linked. It means the gene that makes this particular clotting factor is on the X chromosome, so it's found more often in males than in females. Too much can cause what's called thrombosis. Thrombosis is an inappropriate clot. That inappropriate clot can form somewhere, and this can happen through inflammation. It may break off from an embolism. That is a floating clot. And that embolism is going to find its way to a small blood vessel in some part of your body and cut off the blood supply to that part of the body, and that can really be dangerous if it happens in the lungs, the brain, or the heart, the coronary blood vessels. So this can cause a pulmonary embolism, a stroke, or heart attack if you have a broken off inappropriate clot. There's ways to treat that. There are anticoagulants called coumarin, which is really rat poison. Aspirin helps to, because aspirin inhibits the formation of carcinoids, and thromboxane A2 are the carcinoids. Leeches, they have an anticoagulant in the blood. That's how they can suck blood, and they're used sometimes in attaching fingers and things because they suck up the blood that's leaking out. You can dissolve clots with something called kinase, which is a bacterial protein or tissue plasminogen activator, which initiates plasmin, which dissolves clot. And here's the, whoops, and the last thing we know about is if you slow blood down, your blood, there's always a little bit of thrombin in your blood. It always has a little bit of ability to clot. And usually that thrombin is diluted, so that's the dilution. But if you slow blood down, it starts to build up. And if you slow blood down enough, you are at great danger of making a thrombus. And so that's like for example, sitting down for too long. So they tell you when you go onto an airline flight and you're sitting out for hours and hours, the blood starts to pool in your lower extremities. The blood starts to really slow down, and inappropriate clots can form. And you're going to break off from an embolism, So that's what they tell you in the wrong place. Every once in a while, get up, walk around, move around, squeeze those muscles even sitting in your seat. It's really dangerous. It's to be immobile, to sit down. Okay. And on that note, that's the end of Blood3. See you later, and then we'll move on to the heart chapter next.